to properly appreciate axioms and definitions, you need to not only look at examples where they make sense, but you need to look at some other examples that kind of stretch your idea of what these things might mean. And do they still make sense? So we're going to look at spheres. So if I want to think about spheres, are spheres a set of points? Yes, a sphere is also a set of points. We're not going to use E2 for a sphere, but we're going to say, I wonder which ones of these properties still works for spheres. So if you're on a sphere, can you measure a distance between any 2 points? So I would like to appeal to a sphere that I hope you're all familiar with. I hope you're all familiar with the Earth. I hope that you all were in an elementary school that had a globe in the classroom, and you spent some time spinning that globe around and finding different continents and different places on the globe. So I'm going to use Google Earth to think about spheres here. So this is going to be my sphere of the moment. Yeah, that's good. Okay, so there's my Google Earth sphere. And I want to think about if I pick any 2 points on the Earth, can I measure the distance between the 2 points on the Earth? Yeah, I think I can. So, certainly Google Earth thinks that it can. It thinks if I pick this point over here in North America and this other point over here in Africa, that it can measure and tell me how far apart they are. And of course I can go from here to there this away, and I could also take a flight that went around the Earth the other way and went west and across Asia and back over down to Africa. But that would give me a longer path, right? And so distance should always be my shortest distance from here to there. Now, when I'm thinking distances on a sphere, I am thinking distances that you would walk or fly or drive around the Earth. You're not allowed to take the distance that happens where you dig a hole through the center of the Earth to get to the other side. That's not what we're thinking of. The abstract mathematician thing would be to say, okay, but the sphere is just the outside of the globe. The inside, that's a ball. If I want to include the inside, I want to call it a ball. And if I'm just looking at the outside like a soap bubble, then that's the sphere. So I'm only allowed to go along the soap bubble surface, or along the surface of the Earth. So there we go. But that sounds good. No matter how you get from here to there, there's got to be one path that is shortest. All the other ones are at least as long as that, and we're going to call that the distance. Check. All right, so it makes sense to assign a real number that is positive or 0, that's called the distance, and that distance would be 0 if and only if the points were the same. Yep. The only way to get a 0 distance is if you don't move. The distance from A to B is the same as the distance from B to A. Yep. If I fly from North America to Africa, and then I fly back again along the same route, I'm going to get the same distance traveled. Depending on how the wind is blowing, it might take me a little longer or a little shorter, but the actual number of miles, that's going to be the same. The triangle inequality, that says when I measure that distance from A to C, I'm always picking the shortest possible one as the distance. And so no matter what routes you take, so you might say, oh, I've got a direct flight, or I'm going to fly by way of this other city. All right, so there's no way to take an indirect flight and go to a different city and go fewer miles. You've always got to go the same number of miles or more by adding a stop to your route. So that's your triangle inequality. So in fact, the thing that you would think of as distance on the Earth totally works for distances on a sphere. And then we come down to line segments. All right, so that's the segments on the shortest path. And so my Google Earth will show me a shortest path there, sure enough. Now, some interesting things happen because, you know, you can go all the way around the Earth and come back to where you started. But only if you can make this work right. I'm not very good at this. All right, let's try an easier one. I'm going to turn on and I'm going to ask Google Earth to show me the latitudes and longitudes on the map. And I'm going to pick the equator here. And I'm going to measure some distances between points on the equator. And that's nice because, yeah, why is this not working? Oh, because I turned it off. Okay. So if I go from a point on the equator to another point on the equator, there we go. And then another point on the equator. All of those, that's going the same thing. So if you look at that line that's stretching out along the shortest path, that line is staying on the equator. And so if I pick another point on the equator, that's going to be on that shortest path. And that makes sense as I go around and around and around. So this makes sense for distances on the equator, so long as I'm not going too far around. But an interesting thing happens if you try to go a long way around. So I want you to imagine this. All right, so I'm picking this point on the equator that is in, it'll be in Ecuador. All right, so that's in South America on the equator. If I go all the way around the Earth, here to there, and then some more past Africa. Here we go around the equator some more. Oops. I have somehow moved my Earth out of where I want it to. Looking past Australia to the south, coming back around, nearly back to Ecuador. Now, when you think about going all the way around, when I get back to here, and I want to measure the distance from here, let's pretend that's the Galapagos Islands, to Ecuador, I don't want to measure it by going all the way around the Earth. I want to measure this shortest distance between Ecuador and the Galapagos. So the segment that goes the short way from the Galapagos to Ecuador is a segment, but that line that goes the other way around the Earth doesn't fit our definition of a segment. And you get into trouble when you try to use this definition, say, of a ray that worked really just fine when we were looking at segments on a flat plane. So when I had segments on a flat plane, I had A, and then I had B, right? And I said, okay, I want everything on that segment. Check. Segments are still making sense on a sphere. And then I want everything where I can make this segment. And as I go from A to X, that's going to go through B. All right, so on a sphere, So on Google Earth, if I want to do that, if I say, all right, here is going to be my segment. So I start off by making, let's make this segment. We'll go from somewhere in Mexico to like up in Maine or Canada or something. And then I say, okay, now what I want is I want all of the segments. I want to include all of the segments where if I start at A, which is down there in Mexico, and go to the end point, that segment is going to go through point B up in Canada. And that's going to work until you get about over here. But then, when I go just a little bit further, if I want the segment that goes from down there in Mexico and ends up over here, that shortest path isn't going to go around the Earth this way. That shortest path is going to go around the Earth the other way. And so my ray, which that definition in my flat plane on a piece of paper, I can just keep extending that ray out just as far as I want. If I use that same definition on a sphere, at some point it's going to stop, and that's going to be the furthest I can go and still keep this definition of the ray. So that's a place where I would need to change my definition in order for what I do on a sphere, or for what I do on the plane, to also make sense on the sphere. So if I'm changing things to a sphere, then my distance axiom is still happy, and that works fine. And my definition of a line segment works pretty good. I have a prompt for you for one of the assignments, for the assignment coming up about spheres, where one of the things I'm going to ask you to do is going to not work with this definition of line segment. Turns out you can pick a couple of points on the sphere where looking at shortest paths doesn't give you something that you'd think of as being a line. I'm going to just leave that for you to find. When you get down here to ray and infinite line, we really want to have something that's going all the way around the sphere. So I want an indefinite line to go all the way around the Earth. And it turns out that this definition is going to not quite do it. This is going to not go all the way around the Earth. It's going to go most of the way around the Earth. And then there's going to be a little piece where it doesn't connect. So these definitions don't really work well for a sphere. They don't give us the thing we want to have when we want to talk about lines on a sphere.